Hello everyone. So kule video sizodiscussa a question from Maths paper 2 grade 10 taken from 2017. Right? Sizokwenza question 5 labathi khona given that f of x is equals to sin x minus 1 and g of x is equals to 2 cos x for x between 0 and 270. Sketch on the grid provided in the answer book the graph of f and g for x between 0 and 270. Right? Notice la kule question but sketch. Right? So if you sketch a graph, it means that you have to show the critical points only on your graph. You don't have to plot. There's a difference between plotting and sketching, right? So now plotter is when you do that table. Let's say now plotter, let's say maybe you have now plotter, let's say maybe you have a function y equals to x, and then wenza le table le the xy, and then you start by choosing values for x, and then you know the values of y. Whereas with if x is 1, y is 1, if x is 2, y is 2, and if x is 3, y is 3 also, njalo njalo, right? So when you are doing this, mase uya ku Cartesian plane yakho uzo angeke ibe straight again. So mawuya ku Cartesian plane yakho uzoplotta these points, right? Uzokhetha x1, y1, x2, y is 2, x is 3, y is also 3, right? And then if you plot, uzo selecta ama coordinates according to this table kule graph yakho, right? And then you'll just connect the dots, right? This is not sketching, it's plotting. But then if you were to sketch the function, the graph of this function, you look for the critical points, right? The critical points, x-intercepts and y-intercept, right? So x-intercept, you let y be 0. You know when y is 0, x is also 0, right? Therefore you will have x coordinate, x-intercept 0 0 rather, right? And then also y-intercept, you let x 0, and then from this function, if you let x 0, you'll see that y is also 0, right? And then when you sketch, you'll just have a straight line passing through the origin, right? So this is how you sketch. And then the same thing applies for trigonometric functions, right? So it for trigonometric functions, just know the standard function and what's the graph yakon. Like for standard function yaga sin x will be f of x is equals to sin x, right? This is the standard function. And then when they say minus 1, they are just shifting this function, right? And then when you sketch a standard function, hey, sorry again guys, ngiyazama ukuthi draw straight but then I can't. I'm going to draw straight as I would the pepeni. Okay, so most sketch a standard function. Siyazi ukuthi you'll have your turning point at 90 degrees, your x-intercept at 180, another turning point at 270, and another intercept at 360, right? For x between 360 and 0. Right, yazi ukuthi graph yaka sine izoba so, and then we have 1, we have minus 1. Graph yaka sine will be like this. Right, so we'll have our turning point la when x is 90 degrees, and our turning point here when x is 270, and this will be our intercept. Right, and then when you are sketching the graph of sine x minus 1, you are just shifting this standard function 1 unit down. Right, so the point leli you'll shift it 1 unit down lizokuza la. The point leli you'll shift it 1 unit down lizokuza la, and then the point leli you'll shift it 1 unit down lizokuza la. Leli again you'll shift it 1 unit down from here to here, and then leli you shift it 1 unit down, and then now you connect the dots. Okay, I see straight again, but this is how it should be. You are just shifting the standard function 1 unit down. Right, so now this will be the graph of sine x minus 1. The same applies for cos. Siyazi ukuthi the standard function for cos will be g of x is equals to cos x. Right, now the standard function will look like this. For x between 0 and 360, you'll have 90 degrees here, 180, 270 and 360. Right, now here you'll have 1, and then the graph of course will look like this. Excuse the shape guys, I'm going to draw here on the screen, but then I can draw, but then live screening it's a bit difficult to draw. So the graph here course will look like this. Right, this is the graph of cos x. Now the graph of 2 cos x, you are just multiplying every point on this graph by 2. Right, so now this point you will multiply by 2, it will come here, and then this point y is 0, you'll multiply 0 by 2, which is just 0, and then this one is minus 1, you'll multiply it by 2, it will come down here, and then this one is 0, you'll multiply 0 and 2, you'll just get 0. This one is 1, you'll multiply by 2, it will go there. Right, so a graph here 2 cos x will look like this. Right, it will look like this. Okay, sorry I can't draw kuhle la screen, but then ngizokudraw iphepheni and then send pictures of the sketch to you. Right, so now into ebalulekile ngileyo. So now if you can draw these two graphs, the standard function for cos and the standard function for sine, all that you now do is only shift your here you only need to transform the standard function by shifting it 1 unit down, and then here you only need to transform the standard function of cos x by multiplying every point by 2. Right, so and then when you draw them Cartesian plane, they will look like this. Let me try draw them on the same set of axes. Right, so we'll have our Cartesian plane, they want us to draw for x between 0 and 270. Here we'll have 90, here we'll have 180, here we'll have 270, right? And then the graph of sine will be like this. Sine x minus 1 will be like this. Nope. Sine x minus 1 will be like this. Right? Sine x minus 1 will be like this. And then sine x minus 1, this one is 180, and then now 2 cos x minus 1, sizoba no 1, sizoba no 2. 2 cos x minus 1 will look like this. 2 cos x minus 1 will look like this. Right, so now this will be the graph of f and the graph of g drawn for x between 0 and 270. I'll send sketches right. Just draw a paper and then take a picture. Okay, so now answering the other questions, but write down the following: the amplitude and the range. Okay, so the amplitude and the range. So the amplitude of G we describe anjani amplitude. So the amplitude, you will look from the x-axis to the turning point of that function, right? So you'll see the distance from the x-axis to the turning point is 2. So the amplitude of G will be 2, right? Will be 2. And then the range of f. The range a function is now ufuna ukuthola i-range ye function focus ku y-axis. You'll look for the values of y where the function exists, right? So this is the graph of f. You will see the graph of f exists between the range of -2 to 0, right? Because above the x-axis we don't have that graph of f. So now when you're writing the range of f, you'll say y is the element of -2 to 0. That will be the range of f. And then now what you use the graph to determine the following: the number of solutions to f of x equals to g of x in the interval 0 to 270, right? So ngamanye amagama bathi how many points of intersections are there. When f of x is equals to g of x, those are the points of intersections. So they want us to count the point of intersections of these two graphs in this interval of x between 0 and 270, right? So now going back to our sketch, we see the graphs intersect here when x is 90, and then they intersect here when x is between 180 and 270. So go 5.3.1, there are 2 points of intersections. So which means there are two solutions to this equation, right? Now moving on to 5.3.2. 5.3.2, so la 5.3.2 but they want us to determine the following using the graph. Okay, using the graph saying let me try go back to the graph. So using the graph determine the values of x in the interval x between 0 and 180, for which sine x is equals to 2 plus cos x, sine x equals to 2 plus 2 cos x. So lapha bathi we're focusing between 0 and 180. 0 and 180 is this region here, and then the graph of sine x and the graph of 2 cos x plus 2. So the graph of sine x will look like this. In this region it will be like this, and then the graph of 2 cos x plus x, sorry, the graph of 2 cos x plus 2 will be so this one is the graph of sine x, right? This is the graph of sine x. I'll draw in a different color. So this is a graph of sine x. This one will be the graph of sine x, right? And then the graph here is sine x, ne? And then we need to draw a graph here 2 cos x plus 2, right? So learners in this region, notice what this is the graph of 2 cos x. This one, long trace at this line, this is the graph of 2 cos x. And then when you say plus 2, it means you will transform this graph of 2 cos x and shift it 2 units up, right? So when you shift this point here 2 units up, it will go there. And then when you shift this one 2 units up is where somewhere there, which is 4, is where somewhere there. And then when you shift this one, this point 2 units up, it will go here, right? And then that graph of cos x will be something like this. I'm going to draw again. So it will be something like this. Connecting llama points lawa, it needs to be sort of like straight line here. Connecting these points, it will sort of be like this. And then now in this region yaga x between 0 and 180, they want us to calculate to write down the values of x for which these two graphs are equal, right? Notice what the graphs are equal when x is equals to 180. So therefore lapha ku 5.3.2 our solution will be x equals to 180 degrees, right? So it's a bit difficult to explain this properly because these graphs are not drawn to scale, right? So if I had a graph paper and had the graph drawn to scale, it would make more sense, mass and Kaza. But then the trick to trigonometric functions is to know the standard function. If you can sketch the graph of sine x and sketch the graph of cos x, nabaseke bakunikela igraph enye nenye yaka sine x plus 2, maybe you'll be able to sketch it if you can sketch this standard graph. Even if they say 3 sine x plus 5, you will be able to sketch it if you can sketch the graph of sine x alone. Into ozoyenza lapho, you'll be just transforming the standard graph. For instance, in this case, you'll multiply every point in the standard graph by 3, and then after that shifting it 5 units up. And then if maybe they say sine 2x, that's when maybe it can be a bit tricky. Lapho sozo transforma I period yakho, so you will divide these points by 2. Let's say maybe this, how do I explain this? Let's say maybe this is your graph of sine x, right? Here we'll have 90 degrees, here we'll have 180, here we'll have 270, here we'll have 360. Now this is the graph of sine x. The graph of sine 2x, you will divide these points, these critical points, by 2. So when you say 90 divided by 2, you'll have your turning point at 45. And then when you say 180 divided by 2, you'll have your x-intercept at 90. And then 270, it will take you to 270 divided by 2, it will take you to 135. That's when you'll have your other turning point. And then 360 divided by 2, it will take you to 180. So sine 2x is just the compression of the period, right? So your graph will sort of look like this for sine 2x, right? So my point here is know how to sketch the standard function for sine x. And then when they say sketch sine 2x, you just divide every critical point in your function by 2. And then if they say sine x plus 2, you just shifting the standard function 2 units up. The same applies for the graph of cos. So yeah, we'll end here for this video. If you have more questions, feel free to ask me lapho ku WhatsApp. Yeah.